Hello everyone. Today we're going to talk about thermodynamics and energy. Thermal energy can do mechanical work, but every time energy is transferred, some is lost as heat. This is the foundation of thermodynamics. So a system with thermal energy contains particles in constant random motion. This internal energy has the capacity to do mechanical work, that is, to exert a force over a distance. The clearest example of this I can give is if we have gas under pressure. When a hot gas expands, it pushes against a piston, which converts thermal energy into mechanical work. All right, that's an example of how a internal energy system has the capacity to do mechanical work. Okay, so the first law of thermodynamics. So the first law of thermodynamics states that the change in internal energy of the system equals the heat added to the system plus the work done on it. So the formula is this here. So the change in internal energy is equal to the heat added to the system plus the work done on it. So Q represents the energy, Q represents the heat added to the system, and W is the work done on the system. So Q is heat. Okay, so this is a direct consequence of the law of conservation of energy. Energy cannot be created or destroyed, only transferred or transformed. Any energy entering or leaving a system must be accounted for in its internal energy. So this here represents the internal energy, or the change in internal energy. Okay, so in any real mechanical system, energy transfers and transformations are never perfectly efficient. So some energy is always lost to the environment as heat. That's through friction, air resistance, sound, or deformation. So we have mechanical energy produces useful work, but it also has heat lost to the environment. So this means that the usable energy available to do work, it decreases with every transfer, because we always have some of that heat or energy being lost to the environment. So this is why no real system can be 100% efficient. Some thermal energy is always dissipated into the environment, and it cannot be recovered as useful work. So, to summarize, a system with thermal energy has the capacity to do mechanical work. Thermal energy drives particle motion that can exert force over a distance. The first law of thermodynamics states that any change in internal energy is equal to the heat added plus the work done, which is a consequence of the conservation of energy. In all real mechanical systems, energy transfers result in the heat loss to the environment, which reduces the amount of useful energy available.